SAS demonstration, more arrays. In this demonstration, I am going to make use of the programs I used for the topic of restructuring data and show how arrays can be incorporated into the data step. I'm going to start with the data set that was on EMG values for patients who were given different types of music to listen to, and the EMG value was recorded in the left brow region. And in this first part of the program, I am not going to restructure the data. All I'm interested in doing is taking the log of the EMG values for each of the subjects that participated in the study. So I'm creating a data set called single, and I'm inputting subject EMG values at trials 1 through 3. And then I'm creating an array called log trial, and I'm creating 3 new variables, L trial 1, L trial 2, and L trial 3. And then I'm creating a second array called trial, which is going to have our original trial EMG values. And then I'm going to simply have a do loop with an index variable I going from 1 to 3, and I'm saying that log trial of I equals the log of trial I. So basically what I'm doing is I'm saying that for the first time we go through the loop, for this first observation where the EMG was 143, I'm creating a new variable, L trial 1, which equals the log of 143, which was our first observation's EMG value at trial 1. I also want you to notice that within this do loop, we can actually reference an array within a function. We did this when we were using the log function here. So let's go ahead and run all this code. And we see here are our 22 observations. Here were their EMG values at trial 1, trial 2, and trial 3. And here are the log values, the log EMG values at each of the 3 trials. And again, the index variable I is included on the data step, and it has the value of 4 because we went through the do loop 3 times, and then when I equals 4, we did not go through the do loop a 4th time. So that when the data set was created after the end statement, I had the value of 4. Now I'm going to make use of the EMG data, and I'm going to show how we can restructure the data set so there are multiple records per patient, and I'm going to make use of array statements to restructure the data set. So I'm starting by creating my data set called multrec, and I'm bringing in the original data set single, and I want to create 3 observations per subject. I'm also interested in including the log of EMG for each of those 3 observations per subject. Notice in my do loop, my index variable is called trial. So I'm expecting then that on my new data set multrec, there's going to be a variable called trial. The other thing that I'm doing is that within the do loop, I have an output statement. So each time SAS increments through this do loop, an observation is going to be outputted. So we are going to be outputting 3 observations per subject, and we can do that right within the do loop. And then at the end, I'm not interested in keeping these values trial 1 to trial 3 and L trial 1 to L trial 3, because in my new data set I'm going to have the variables EMG, log EMG, and a variable trial, which is going to indicate which of the 3 times the subjects were assessed their EMG value. So let's go ahead and run this and take a look at our new data set, multrec. And we're only going to print out the first 30 observations. So the variables we're printing out are subject, EMG, trial, and log EMG. So here is a listing of the data set with multiple observations per patient. So we have here for subject 1, we now have 3 observations for subject 1. that subject's EMG value at trial 1, at trial 2, and at trial 3. Now the reason this variable trial is on the data set is because we used it as our index variable. And notice that this variable trial takes on the values of 1, 2, 3 for each time that we incremented the do loop. And the reason that it takes on these values of 1, 2, 3 is because we had an output statement within the do loop. So let's go back and look at the program so I can make this clearer. So here, notice in our do loop we have an output statement. The first time we go through the loop, we are outputting the first EMG value for that observation. And so we're setting EMG equal to the first EMG value, or trial 1. We're also taking the log of that EMG value, and then we're outputting right at that point. So at that point, trial equals 1, EMG is the value of trial 1, log EMG is the value of the log of trial 1. When we go through the loop again, trial equals 2, EMG equals the value of trial 2, the log of EMG equals the log of the EMG value, trial 2, and then we're outputting a second time. And so if we go back and look at our output, we see that instead of having trial just be one number all the way through like we saw with these other index variables, trial now takes on the values of each iteration of the do loop. And so we've automatically created this new variable trial just by having in the do loop with the index variable. Now I'm going to show how arrays can be used when we are going from long to wide restructuring, or when we are taking multiple records per patient and outputting a single record per patient. So we're going to again make use of that Hamilton depression score data set, and I'm going to show you the code for how we do the method of restructuring data where we do it within the data step, and I'm going to include an array this time. So here the code starts out very similar to the code I showed you when I did this demonstration program on going from long to wide restructuring. So I'm bringing in the data set RISE bit 4, which is an Excel spreadsheet, and I'm first sorting my data by patient and week as I did previously. So we'll just take a quick look at what this data set looks like. And here you'll recall this is the data set where we have multiple observations per patient representing each week that they were treated, their gender, their diagnosis, the IPL level, and their Hamilton depression score level and their DPL level at each of the weeks. In the next step, I'm creating a data set with all the repeated values for a patient on the same observation. So again, we are going to have the retain statement that we used when we initially looked at this program. But I'm planning to replace the following code with an array called misser. So when I originally showed you this program, we had a code where I said if first dot patient equals 1, then do, and I set all these new variables equal to missing. Here, instead of having these separate statements, HDRS 0 equals missing, HDRS 1 equals missing, I'm defining an array called misser. And there is no explicit subscript for this array because we want to use a do-over statement which operates on the entire array. And we haven't done a do-over statement with arrays processing before. When we use the do-over statement, explicitly subscripted arrays are not allowed. So here we're defining our array with no explicit subscript, and we're listing the variables that are going to be in this array. And we have 8 variables. And then we have the statement if first dot patient, then do over misser. And then we say misser equals missing, and then end. This statement sets every variable in the array misser to missing. And the reason I need to set all these variables to missing is that I set all the new variables I'm creating to missing whenever I'm first processing a patient. So the first time we're processing an observation from a particular patient, we need to set all of these variables to missing. And then we're going to make use of the retain statement as we process through each week of data and holding those values before we output a single observation per patient. So basically, I haven't altered the data for restructuring this data set except for including this array misser for when I wanted to set all the values of the initial observation for a particular patient to missing. So again, I'm just trying to show how arrays can be used to streamline some of the statements that we need to use in our data step. So if we run this code and do a proc print, we see here that it's the exact same output that we got when we ran it when I first showed you this program of how to restructure data within the data step. We now have a single observation for each patient with the values of Hamilton Depression Score and IPL taken at each of the 4 weeks, but it's on a single row per patient. This concludes the SAS demonstration using arrays to restructure data sets.